Hello, my name is Anubhav, and today in this video I'm going to be talking about Cisco Multicloud Defense Centralized Security Model. In the last video I talked about multi-cloud defense and I gave you overview of the service. I talked about different traffic flow and protection options available in multi-cloud defense. But at a very high level I will quickly run through this particular slide. If you have not watched my first video, I would highly recommend you to go to that video and watch it first. I will add link to that video in description of this video as well. So Cisco Multicloud Defense is a SaaS-based offer available today globally. Using this offer, you can protect your workloads and applications in multi-cloud infrastructure. At a very high level, Multi-Cloud Defense has two components. First one is the controller, which is built on highly scalable cloud native constructs, and it is highly scalable. Controller controls everything in your infrastructure. So you onboard your cloud accounts and then you deploy gateways. These gateways are deployed as platform as a service because the entire lifecycle management of these gateways are controlled by Multi-Cloud Defense controller. You can add these gateway into your account to protect your Ingress, Egress, and east-west traffic flow. Now, in terms of what kind of benefits we give with multi-cloud defense is you can enable visibility. When you onboard your account, you can enable visibility. You can automate security deployment. So controller is smart enough to deploy and insert your gateways in your data path, and it will handle all the complexities related to routing and connectivity. Now, in terms of policies, you define your unified dynamic policies and you attach it to your gateways running in AWS, Azure, GCP, or OCI. And all the options you see in controller UI, those options can be automated using Terraform and API as well. And on the eventing, we integrate with SIEMs like Splunk, Datadog, and others. Now, before I talk about centralized security model of AWS, it is really important to understand what centralized security model is. So in centralized security model, instead of deploying gateways in each application VPC, what we do is we create a dedicated security VPC, and inside of that security VPC, we deploy our gateways, and those gateways can be Ingress gateways for protecting your inbound traffic, or Egress gateway for your egress traffic and east-west traffic. Now, once these gateways are deployed in the security VPC, we connect your application VPC back to your security VPC and then bring your traffic to security VPC for inspection before sending it to destination VPC. If you look at this architecture looks really simple and it is highly scalable architecture. But if you look at number of components involved in this architecture, it is really huge. So you have transit gateway connecting your application VPCs to your security VPC. You have VPC attachments where you attach your application VPCs to transit gateway, and then because of the nature of traffic and nature of security appliances sitting in security VPC, we require symmetry in the traffic flow. That's the reason we also use Geneve, and Geneve requires us to add components like gateway load balancer endpoints, and then you require route table for switching your traffic to the right infrastructure for inspection. And in addition to that, specifically for Ingress use case, you need some configuration on network load balancer as well. So at a very high level, there are a lot of moving components in the architecture, and your operational resources should have complete understanding of each and every component before you deploy it. But beauty of the solution, when you use Cisco Multi-Cloud Defense, you don't have to worry about anything because controller will ensure that your VPCs are created, your route tables are created, your gateways are deployed correctly, your transit gateways configured, your route tables are configured. Now, if you look at the architecture on the right hand side, we have a security VPC, and in security VPC we have multi-region architecture. So you have AZ-A and AZ-B, and we deploy our Ingress and Egress gateways inside of the security VPC. Along with that, we also use transit gateway, which is in the middle, connecting to all my application VPCs. So if you look at this particular flow or this particular architecture, it is specifically for Ingress use case. So in this example, what we use is we use the internet gateway from where our traffic will land on network load balancer. Now, once it is on network load balancer, behind that network load balancer, we place our Ingress gateways. And The moment traffic is received on Ingress gateway, we process traffic, and based on our security policy, if traffic is allowed, we send it to transit gateway, and from transit gateway to the destination VPC. And this architecture is pretty scalable because by default we enable auto scaling, and auto healing is also enabled. So if there is a failure of any instance, we quickly replace that instance with the new instance. But if you look at this particular architecture, we define the complete security VPC. When I say define, we orchestrate complete security VPC, we orchestrate network load balancer configuration, we add new gateways whenever and wherever these gateways are required. You can control your security policy directly from your SaaS portal. In addition to that, we also orchestrate configuration on transit gateway. So if you already have transit gateway, we can attach to your existing transit gateway. If transit gateway is not there, we can orchestrate configuration on the transit gateway as well, and then we attach to the application VPC. So if you remember in the previous video, I talked about three-step process wherein you first onboard your VPC, enable enable visibility on your account, and then you protect your VPC. The moment you click on protect your VPC, we ask you to select what model you want to deploy, whether you want to go with distributed security model or a centralized security model. Now, if it is a centralized security model, we ask you to click on secure VPC. The moment you click on secure VPC, we switch routes. So by default, we deploy everything. Before switching routes, we ask for your permission. When you say yes, we are ready to switch routes, we make changes to your VPC subnet routing so that your traffic can flow through the right devices and through the right security gateways. The other type of use case is is egress use case. Similar kind of architecture, but since it is egress use case, traffic is initiated from the application in the application VPC. We forward this traffic to transit gateway. Transit gateway then uses the VPC attachment going back to security VPC, and instead of sending it to the gateway straight away, we send it to gateway load balancer endpoint, and gateway load balancer endpoint has gateway load balancer inside the security VPC, and on the other side of the gateway, we have our egress gateways. Now there is a Geneve running between the gateway load balancer and our egress gateways, and we use egress gateways for egress traffic flow. Now again, coming back to the orchestration, we orchestrate your security VPC, we orchestrate configuration on your gateway load balancer, we orchestrate deployment, insertion, auto scaling of your gateways. You can instantiate security policies directly from Multicloud Defense UI, or you can use Terraform scripts as well. In addition to that, if there is a transit gateway, pre-existing transit gateway, we use that. Otherwise, we create a new one, we enable attachment. So it is a pretty scalable architecture, and you don't have to worry too much about how everything is stitched together, because from the point of view of the person who is configuring this, will just define the end requirement that I need a security VPC with Ingress gateway and Egress gateway, and rest everything is automatically orchestrated by the controller. The other flow, important flow, is your east-west traffic flow, VPC to VPC connectivity. So in this example, we have dev VPC talking to shared VPC, and this traffic flow is not sent directly. Even if both VPCs are connected to a transit gateway, what we do is we receive the traffic, and based on the way routing tables are configured, we forward this traffic to the gateway load balancer endpoint, and then from gateway load balancer endpoint to gateway load balancers, and then to our egress gateway. So egress gateway is used for your egress traffic as well as your east-west traffic. Again, the complete automation and orchestration related to security VPC, related to deployment of your gateways, your transit gateway, your gateway load balancer, and your route tables. Everything is done automatically by multi-cloud defense controller. So when you deploy such kind of architecture in cloud, this is a scalable architecture based on the AWS recommended architecture. But you don't have to worry about complexities related to route table, complexities related to transit gateway, complexities related to gateway load balancer, because the controller will handle all the complexity in the backend. The other common use case is you have your VPC, and inside of that VPC you have multiple subnets. And when you have multiple subnets inside VPC and you would like to have inter-subnet filtering based on your routing, so there is something known as more specific routing feature which is available on AWS. We use that particular feature to route traffic to security VPC for inspection. So one way to protect this traffic is to use security groups, but security groups are L3, L4 groups. And if your requirement is beyond L3, L4, you want to add advanced security features, you can use centralized security model, place your Ingress gateways or Egress gateways in your security VPC, configure route tables accordingly, and we will ensure that your traffic will reach security gateways in the multi-cloud defense gateways and security VPC, and we filter traffic based on your security policy and we send it to the destination subnet. So the intention of having all the architecture in this video is to tell you that there are too many moving components as shown in this particular slide. And in the end, what you do is you will focus on creating your security policies. You will have less focus on how will I configure gateway load balancer, how will I configure Geneve, how will I configure route table, how will I configure network load balancer, because all the non-operational work is handled by gateway load balancer, and you can focus on having the right security model. You can focus on having the right security policy for your infrastructure rather than worrying about the entire underlying cloud network. So in this video I covered the architecture, and I hope you enjoyed this video, and stay tuned for the next video on multi-cloud defense. Thank you for watching.